So today it will be, I just want to share some of my experiences, uh, in life over time. So one of the realization that I had is when I was doing academic research. Academic research is like, and the leading industrial lab research, they go hand in hand. And so when I was in WINLAB doing things, I was very excited on doing things that this is going to be deployed. But at that time, I was not mature enough to realize that, hey, it takes a long time before things actually get deployed. And over time, I realized that, these things happen at 10 years. It takes at least 10 years. And then when there is some inkling of business sense, then the pragmatic industrial lab, they start the research, and then they do a business case, and then early adoption starts, and then the mass deployment. So it's like at least 15 years, and there are many, many examples of things that I've seen in life. And one of the things that, and so I started here, in the Bell Labs, then I've been doing some of the R&D labs at Infosys and Accenture, and then I moved further to the left to the early adoption, now trying to commercialize technology. And so I've been moved too far, and maybe it's time to circle back and see that how, again, bring that perspective. So what I'll do is I'll just first tell you that when research started in wireless sensor network, that is one of the early things that Princeton had something called ZebraNet. So this was a sensor network used to track the zebras. People were really trying to see what can be done with sensors, and a lot of interesting things were happening. But this is like 2002. Even this was a paper published in 2002, so it was about late 90s or early 2000. This work was going on. But until about 2012, things didn't take off. IoT sensors, things was not happening. So because there was no industrial investment. But what has started happening is now, one of the things is when there is a business case for new technology in the context of an industry, investment happens and new technology deployment happens. So I want to share with you some of my experiences along these lines. So today I'll talk about digital manufacturing. So there are a lot of digital technology we all hear about. So for example, the glasses, whether it's a HoloLens or Google glasses, things like that, that is there. Drones, 3D printing, blockchain, pivotal cloud foundry, which is the multi-cloud, SDN fabric, artificial intelligence, machine learning, deep learning, all of these things are happening, and these are disrupting industries by industries. I'll give you examples of how industries are getting disrupted. If I look at a banking industry is getting disrupted because of blockchain, Bitcoin, because of payment, and all of those things are changing the way the banking happens. And these are huge changes in terms of economic changes are huge. If you look at retail is changing. There are applications whereby you could just point a mobile at the thing and find out what the prices are, and technology is changing things. Netflix, when I was growing up, I used to go to Blockbuster to pick up all those video tapes and all that. Today, those things are history. Completely, Netflix is there. That's where you see all the movies and TV shows. Internet. I remember that in the AT&T, it was 1994 or something. We talked to AT&T and said, people are sending voice packets over internet. AT&T exec said, guys, don't worry about it. Voice is a completely different ball game. There's no way some crazy researcher is sending papers, sending voice over the internet, but that's only research. But look at what has happened. Today Skype for business, WhatsApp completely changed the way you do SMSs and messaging. Healthcare is changing. Again, in healthcare, a lot of things are happening in the IoT space. And this is not a mystery. In the oil and gas industry, drones are repeatedly used to sort of inspect the pipelines. Think of the Siberia and some of the areas where humans don't want to go. You're sending drones. You can actually, drones can go along the line, completely take pictures, analyze the images, and this is not science fiction. This is actually happening, and this is how people using technology. And they're disrupted. The oil and gas being disrupted here, healthcare being disrupted here, communication disrupted here, media industry disrupted here, retail disrupted. Banking, all of those things are getting disrupted because of technology. So with this background, I want to show you what are the type of things that we have to deal with. You go to a manufacturing plant. And, I did a lot of writing papers and things like that, communication. And then they'll say, well, this is my plant. So you tell me how you use technology to give me business benefit. So basically we go and say, well, we can use sensors to sort of monitor these things, and then say, well, show me how will you monitor these things. So you go there, stand in front of the humongous machines. If you're not a domain expert, it's very difficult to figure out how you can bring value to the customer. So then we have to show that how I can monitor them, how I can get data from these guys, how I can analyze the data, how I can predict when something is going to fail. The value of these things comes up, yes.
Quick question.
Yeah.
Isn't it naive to imagine that they are not already in a high money industry like gas, oil, mining? They already have sensors all over the place. It's just that it's custom, it's controlled by incumbents.
Correct.
Who are we to come and tell them what they should measure and how to measure it? They're already doing it.
The answer is yes and no. For example, for many of these oil and gas industry, manufacturing industry, they have SCADA systems. They have SCADA and PLCs, they're there. But what happens is, so what happens is, now if you take a manufacturing plant, we're talking about, let's say, take a company, Georgia Pacific. They have 130 plants across the world, right? And different plants will be using different systems.
Okay.
And as a result, you are running the company, you have no clue as to which is doing better, how much better, can I take the best practices, you have no clue. So when you try to optimize across your multiple plants, that's where the data has to be aggregated, you have to create a better view. That doesn't exist today. And also there are very proprietary mechanisms. For example, if you use Siemens equipment, Siemens has their own thing. If you have ABB, ABB has their own thing. Schneider has their own thing. And now how can actually make something which is across all of them? So some of those areas are where challenges are coming up. And the biggest challenges for maintenance, for example, today what happens is, you know how maintenance is done today for these plants? So every 1 year they say, well, shut down the plant. Everything should be shut down. They'll do maintenance and then bring up the thing. But when they shut it down, it's a huge expense. I mean, sometimes you don't realize they're talking about billions of dollars because there's no production for few days. So ideally, you don't like to shut it down. If you can predict when things are going to happen, or do people do preventive maintenance. Preventive meaning that, well, instead of doing it, when things break down, I do it, in schedule. But then if you do schedule, maybe you're maintaining something which does not need maintenance. Things are going well. How do you know that? You get the data. From that you figure out, hey, this machine over there most likely needs maintenance, but this does not. So if you can do predictive maintenance, then it's a huge savings. So the question is, how do you do predictive maintenance? How do you get the data? How do you analyze the data? How do you figure out, when things are going to fail? Another example that we all know luxury ships, right? Then we're working with a company called Man Diesel, that is a company out of Germany, and they make these engines. This is an engine which actually runs this. And they say, well, how can you help me, doing things with an engine? Like, sort of how do you help me maintain the engine doing things better? And then, these are the challenges that when you started collecting data from the IoT, then what happens is when your ship is then mid-sea, it does not have connectivity. So I cannot say I'll ship the data into the cloud, I analyze the data in the cloud and get back to you. But hey, in the middle of the ocean, there's no connectivity. That's where edge comes into play. Can I do things in the edge? Can I do things right there? So that I can do things, round trip time, latency is less, and I don't really have to go to the cloud to do things. That's when edge cloud and edge, these things are becoming important. Give another example. Maintenance. Now maintenance, you'll see that what is there. Now, the challenge that we face as when you go to this company is that, well, this is how my system people do maintenance. How can you help me? Very broad questions. Nobody will tell you that, well, I'm trying to do this routing and this is where the packet has to be, how can I optimally allocate packets? No, people, broad question. This is my people doing maintenance. Tell me how will bring me value. And you have to think that how we can help this guy. How can we help the maintenance? One of the things that a very big thing in the industry is safety. safety is big, that if any injury happens for any of these companies, the amount of money these companies lose is enormous amount of money, because they'll be sued, they'll be taking people off, replacement is difficult, and the amount of money US companies lose is about $200 billion every year on safety. So if I can make these people safer, I'm good. Now the question is, how do you make people safer? So I'll give you examples of how we're working on trying to make the workers safer. Oh yeah, I'm talking about safety. Like these are like the conveyor belts happening, and why is safety is important? Because people suddenly they get entangled, and then people lose their life, or they lose their limb, or something like that. Or this is a realistic case. We're working with the steel plant, and they're moving this molten iron from one station to another by the crane. The crane operator is sitting over there, and he's moving this molten iron. And the poor guy working downstairs, working on the field, the crane operator does not see. There's somebody down there. One drop from here on this guy is finished. So the question is, how can you use technology to make things safer? So this is where, again, the usage of technology comes into play. Another thing that's happening is human-robot collaboration. So this is, again, robotics is everywhere. So you say, well, robots are there, you use robots for various plants. But what is happening is today that you realize that these robots, which are doing a very specific task. But if you want to program the robots to do things differently, if you want an API to control the robots remotely, if you want the robots to do more repetitive tasks and humans to do more intelligent decision making, how do you make them work together? And this is human-robot collaboration, or cobots, is becoming very important in the manufacturing industry. How do you make things happen? So I'll give you use cases, and then I'll talk about what we're doing in some of these places. And another thing is supply chain. I didn't even think of supply chain issue, but again I realized the supply chain is a big issue. In supply, what is supply chain? The suppliers will supply the components to manufacturing process, manufacture the product, send it to the warehouse, distribution to customers and consumers. So this the whole process is involved. And here, coordination is very important. Visibility is not there. So what I mean by that is, let's say you are an automobile manufacturer. The suppliers are sending you various components, brakes and brake pads and seats and tires and all those things, and then you manufacture it and finally you're shipping it to your customers. If somebody asks, can you give me 500 automobiles by next week? You'll not have a good answer, because sometimes you don't know the exact visibility into what's happening in the warehouse, what's happening in the suppliers, what's happening in the supply chain. The real-time visibility is missing. Can you bring that? So with all these trends in manufacturing, that there's a pressure on improving quality and cost, supply chain is becoming global, flexible production models, environment, health and safety, and with all these new technologies, wearable devices, 3D printing, robotics, drone and Internet of Things, this is leading to a huge opportunity. And actually the manufacturing is the largest chunk of the opportunity of $3.9 trillion across the globe. Huge opportunity. That's why this has led to what is called the Industry 4.0. So those who have been following manufacturing, Industry 4.0 is the biggest thing that's happening in the manufacturing process, which is trying to transform the assets, the workers, the processes, and supply chain. For example, Industry 4.0, you see that, what is it? This is the assembly line, things are happening here. You see there's the robots and humans working together. And in the assembly line, the things are flowing through this, and here you are basically doing a quality check. And after the quality check is done, it's a finished good. There is a transport which takes it to third-party logistics, it takes it to the distribution. So this is how Industry 4.0 has multiple things. For example, how do you monitor the flow in real time to eliminate risk, eliminate waste in the production line? Can you do condition-based monitoring? How do you know when this robot is going to fail? And can you actually do condition-based maintenance of the robot? Can you do quality inspection? So this is, again, inspection is a big deal. In the assembly line, when the products are coming out, if you don't predict that something is going to go wrong, a whole batch of defective products come out which are discarded. And that's a huge cost. So the question is, can you predict that something is going to go wrong and take actions ahead of time? So this is where technology camera comes in. You take pictures, and on the pictures you do try to figure out if something is wrong. You try to do some analytics based on if the raw materials are coming out which are defective, and based on that you could predict something is going wrong. So you could do all these predictions for quality. And then once the customer buys your product, then you remotely monitor the products to make sure that the product is up and running all the time. And finally, the logistics part for supply chain. And last but not the least, you want better visibility of the production line. R&D people want feedback as to what we're doing is that the right thing to do, can I improve the product, and even field service has to be deployed in a much more efficient way. So, impact of this Industry 4.0, if that can be made. There are companies, when I was working in WINLAB's, only companies I knew of was AT&T and Verizon, and these are the large telecom companies. But once I started working in this industry, I realized, oh my God, there are companies like ArcelorMittal, there are companies like Georgia Pacific, Eastman Chemical. These are huge plants, huge companies, and they have all this equipment and legacy equipment. And then they're all looking at now we are talking about all these technologies, drones, 3D printing, augmented reality. Now they are telling us, tell me that how you can use all the technology. Don't give me about technology. Tell me how you can help me. So that is where our job comes in, to tell them that how they can use this technology to transform their business. So I'll just give you what are the challenges that we see. That one of the things with IoT is you have to get the data from the machine. So these are the various types of machine, complex assets, and here I have the cloud platform. So if I can get the data from these machines, if I collect the data, then I can do all kinds of analytics, all kinds of software there, all kinds of analytics I can do. I can do asset onboarding, I can do remote diagnostics, predictive maintenance, firmware upgrade. All of those things can be done from the cloud, and you can do the firmware upgrade. But what is the challenge? What is the challenge? Can you tell me what is the challenge? If I have to connect this to the cloud, what is the challenge? What problem do I face? What would be difficult?
Security.
Huh?
Security.
Even before security, first of all, these machines, they don't talk TCP/IP. They have their own protocols. They'll be talking Modbus. They'll be talking, CAN bus. And if you cannot say Modbus, CAN bus, nobody will understand what is Modbus, CAN bus is. So that's like the one simple example. So what we have to do is we have to change this architecture to introduce this notion of edge gateway. So what the edge gateway does is actually it collects data, and it collects data from multiple machines. It collects the data, and then it consolidates and sends the data to the cloud. And from the cloud, you have to combine it with other systems, and then if you want to do over-the-air upgrade, like Tesla, for example, today, they do over-the-air upgrades. For any of these machines, I think one of the government regulations where you have to increase the clearance from the ground. For all the automaker, they take the cars to the dealer so that they could actually increase the clearance from the ground. With Tesla, they send a firmware update over there, and all the cars, they just went up a little bit. So this firmware update over the air is becoming very important, and you need firmware update over the air for many of these machines. So just to give you an idea of the IoT gateway, the edge gateway. So edge gateway, so next level of intelligence. What do you need in the edge gateway? You need the multi-protocol support. As I said, that you need different types of protocols to talk to different machines. And once you understand the protocol, then you can extract the data in JSON format, and then you can push the data into the cloud. Once you push the data into the cloud, you can do all kinds of analytics. So this multi-protocol gateway becomes key. And also you can do edge intelligence, that as you get the data, you don't send all the data to the cloud. If all the machines, the data that they generate, the machines, at the frequency that they generate, the amount of data will be enormous. You don't want to use the bandwidth, you don't want to send the data to the cloud and let the cloud analyze, because in that case you're wasting storage, you're wasting compute. So that is where the edge comes into play. You basically decide what information you want to send and when you want to send it, so that you can reduce the cost on the bandwidth and the storage and the processing. Next level of details, again, as I was saying, that in the edge gateway architecture. So there are the Modbus devices, so you have to have Modbus RTU, then the CAN bus, ECU, OPC server. So these are real protocols that you run into on daily life. You will say that, well, to answer Renanda's question, you go, these guys have those machines, but they have this kind of protocol stocking. So you have to take it to the cloud, then I have to use some kind of gateway, understand the protocol, convert it into a format, message queue, do edge analytics and push it into the cloud. So that's where the challenges come in. And there are just way too many variations of that. I'll talk a little bit about our IoT platform called Looking Glass. So this is our Wipro's IoT platform. And I'll tell you what is unique about this IoT platform. So here, I talked about the edge. So this is where all the devices, they're generating data. Then this data goes to, this is the IoT engine, or this is the cloud, where the data comes in, you analyze the data in real time. Streaming data coming in, do streaming analytics in real time. And based on that, you could send notifications, alerts, and whatever to the various business stakeholders. And in a large organization, which is global, you could have a cloud, you could have a location in North America, you could have a location in Europe, you could have a location in Asia Pacific, and different locations. Now, what happens is today, because of GDPR and other things, people will say, well, you know something, if you are instrumenting my machines in Europe, I don't want the data to go anywhere. The data should be in Europe. China will say, well, get the data and you're getting in China, but I don't want the data to leave China. So now if I have a cloud and AWS has data centers in US and Singapore, obviously that's violating that requirement. So that is why we built the architecture in such a way that I could spin up a cloud in the local region and make the data reside there. The data cannot leave. As a result, I can meet the data compliance and requirement. Well, now the question is, but if I am a global company, I want a global view of what's happening. But if the data is localized, how do I get global view? So that is where, this is, I think, our contribution to the whole architecture. This is where we create what we call hyper-dimensional modeling framework. So this is where we do a humongous graph, semantic graph. We do the asset modeling. And once I do the asset modeling, so here in this layer, I don't keep any data. It just keeps the object indices or the pointers to the data. So that if somebody has a query, tell me the overall status. So here, the HDMF will know exactly which cloud to pull. Oh, I have to pull this data from this cloud, this cloud, this cloud, do a mashup and give the data. So here, this is the control layer. So this is where our data resides wherever they are. So as a result, I don't own data. Data resides where they are. I don't violate any controversy. But here I have the control layer through which I can do all kinds of manipulation of data and give the data back to you. And because of this asset modeling, the other thing that we can do, other IoT platforms cannot do, is today if you go to IoT platform, so Azure will say I have an IoT platform, AWS will say I have an IoT platform. A lot of people will say IoT platform, but their IoT platform is very central to their cloud. But with us, what happens is I can go across different clouds. I could pull the data out of Azure, I could pull the AWS, I could pull the data from GCP, wherever your data might be, or I can give you a single view. So that's the value of the platform. We'll go into details of one of the things that I want to show you how the graph looks like, just to give you a sense of asset modeling. So we are working with a company called Man Diesel in Germany. So they had their engine. So we just showed them, so suppose you have an asset, how we do the modeling. Suppose you have engine 1, 2, 3, the modeling that we do is basically say, well, what kind of belongs to this diesel 4-stroke engine, it belongs to site ABC, and this has a subcomponent called turbo 1, 2, 3, 4, and that subcomponent belongs to man turbo M4 class, which is low pressure turbocharger, that belongs to a turbo compressor. So this is the standard hierarchy of the classes. But in addition to that, we also capture real-time data. That is, if this turbo 1, 2, 3, 4, that has an intake pressure, bypass pressure, and that belongs to the pressure, and this has a value minimum, maximum, average. So I have this asset, I'm monitoring the data in real time. So in this asset model, I'm keeping the time series data, whether for pressure, bypass pressure, continuously against this particular asset. And not only that, I also monitor if the event happens. For example, so here I told you about the not only the hierarchy, but also in terms of what kind of data, time series data that we collect. In addition to that, we have something called events. So if the sensor calibration fails, what kind of corrective action you take? If the pressure sensor failure happens, what kind of corrective action you take? So essentially, this model that you do is not just a hierarchical model, but also what kind of data that you collect in time series data. What kind of actions you take if things are broken. Who owns what? So all of those things overlaid into, so it's a huge control data, and it's very, very important in IoT. When people think of IoT, people think, oh, it's simple. I just put sensors, get the data. But in real life, just putting the sensor, getting the data is the easiest part. The challenge is what do you do with it? And that is where unless you do a very complex asset modeling, you don't get the value out of it. So this is the thing that we have done in the complex asset modeling. And so for us, we can provide an end-to-end services in IoT. I can provide device and sensors. We have the capability for hardware and firmware design. We have the edge gateway. So this is where our multi-protocol gateway resides. We partner with Dell EMC to create this edge gateway. We can do all the edge analytics there, multi-protocol gateway there. And then from the edge, we go to the cloud. So this is where we have in-cloud real-time analytics. And then the two types of analytics. One is real-time analytics. Other is the more historical analytics, that you collect the data over a period of 5 years, 10 years. What can you do with it? So the question, there was some discussion this morning saying, oh, you cannot execute the model in real time because it takes time. So the answer to that is, this is what you do. So this is our IoT platform where the real-time data comes in, and I can do I can push the data into this data discovery platform. This is an analytics platform where I can do all kinds of model generation happens here. And after you develop the model, you push the model back. The mathematical model is pushed back into the IoT engine. So what happens is now, say for example, it's a mathematical model to predict failure. So I have the model running here. Now as the data comes in, I execute the model because that's already just execution part. There's no model development. Model development is the heavy duty part that we do outside the system. After I develop the model, I push it back into the IoT platform. When the data comes in, I execute the model, and based on that, I predict what is going to happen and take action based on that. Now, when I talk to people, say, where have you done it? So I just want to tell you that whatever I'm talking about, this is not on paper. This is not a prototype. So this is a commercial deployment that we have done, and this is for monitoring construction equipment. So this is like construction equipment, and this is a company called JCB. JCB is one of the largest construction equipment manufacturers in the world. So JCB is 100,000 machines across India, that distribute all across India. We monitor the machines every day, continuous monitoring. We started off with 2,000 machines, believe it or not, 4 years ago. And every month they added another 2,000 machines, and today we have reached 100,000 machines. We're monitoring 100,000 machines in real time, 85 million data points processed per day, about 10,000 service opportunities generated, firmware upgrade over the air. So if anything goes wrong in any of the machines, we do upgrade over the air. And it's interesting to say, well, we do upgrade over the air, but very recently we did upgrade over the air, and some of the machines stopped functioning. And then phone calls started ringing, hey, my machines are not working and I'm losing money. And then you have to go fix it. So this firmware upgrade over the air is good. At the same time, it can be disastrous because you are upgrading it sitting in Bangalore, and upgrade happens in Rajasthan, something goes wrong, and some other part of India, so somebody has to go fix it. So why is this working? It's, in some sense you'll say, well, it's just like instrumenting these machines and getting data. So what is the big deal about it? The big deal about it is not the technology. Big deal about it is the business this enables, if problems it solves, that is why it's working. That is why JCB is paying Wipro. What problem it solves? Let me explain in very simple terms what problem it solves. So you manufacture this construction equipment. You sell it to dealers. Dealers get it. Dealers give it to the individual people who are using these machines in the field. Suppose this machine breaks down. So what will the individual guy will do? He'll say, oh my God, I have to get the machine fixed very quickly. So he'll go to some local garage and get a local garage guy and he'll somehow do something. In India, they'll always find something to fix it. But what I've done in the process, the local original JCB part is replaced by some local part. But somehow it got it up and running. So who lost in the process? JCB lost in the process because their part is now replaced by a local part. So that money should have come to them. That money, replacement part should have been JCB's, not somebody else's. So they lost money. The local guy lost time because the machine was down for some time. So what happened now, now that we monitor the machines, we can predict that part in that machine is going to fail. So what happens is I can tell JCB that, hey, I need this part from you because that part is going to fail. I tell the dealer nearby, see if the machine is going to fail near St. Louis, Missouri, I tell the dealer near Missouri that, hey, go get that part from JCB and go fix the problem. So you're creating new revenue stream for the dealer. Dealer was not in the equation in the first place. When my machine broke down, I go to local garage. Dealer didn't even know my machine broke down. Now dealer knows machine is going to break down and dealer is actually fixing it, so it's a new revenue stream for the dealer. JCB wins because now their part which replaces JCB's part, not the third party. And I as an end user win because my machine doesn't go down. So it's a win-win-win. So typically when I go and talk in IoT conferences, and I was talking in Stockholm, and all these guys, they're fantastic technologists, well, but nobody wants to pay for IoT. You know, everybody wants the benefits of IoT, but nobody wants to pay. How do you make people pay? I said, well, in order for people to pay, you have to make sure that all the stakeholders in the value chain, they benefit. It has a win-win-win. If somebody loses, they will not take part. Here in this case, everybody benefits. The OEM benefits, the dealer benefits, the end user benefits. And that's why it's a growing business. Every year they're adding more and more machines. And the business model is also very good. I'm not charging them for the huge platform and things like that. I remember when I was in Lucent, and AT&T Lucent will go and push AT&T, hey, not only this access, but also you take the core, you take this machine, that machine, the whole, a bundle used to cost millions of dollars. Today, nobody is going to pay you millions of dollars. The reason this works is I tell them that every machine that you add, you pay me per machine per month. So the business arrangement here is every machine they're adding, per machine per month. There's no upfront cost. As a result, it's also working. So whoever is buying it is also easier for them to make the decision.
Could you please comment on the communication aspect? I imagine latencies can be very long and bit rates are very slow, so there's really no stressing here on the...
Good question. In this case, yes, you're right. In this case, what is happening, these machines are remote machines. They're using a SIM card, using a 3G SIM card, and they basically are sending their, continuously we're monitoring their battery level, fuel level and a number of things. And the packets are small, there's no heavy information. That's being sent by them, and we receive in the cloud, we analyze it and do analytics and everything. There's a bandwidth, and it's not an issue. But it will become an issue when some of the other things will come into play. But in this particular case, network is not an issue for us.
But I think the best example is where that failed miserably is the Malaysia airline, where they didn't want to pay for satellite feed.
Yeah, of course.
Right, and that's where the cost of communication exceeds the willingness or pain point for the.
Yeah, I was actually surprised that most of the airlines today, they don't have a real-time communication.
They don't
They
want
don't.
to pay, and
Remember the one that
everybody
was-
offers it.
Huh?
The one that was lost and was being searched for a long time.
Yeah, the Malaysian.
The only reason is they never
They
paid
don't
for
want
a
to-
They never
subscription.
paid for communication.
But you know what's actually also, I heard, and I don't
But
have
this is the one you were talking about, not the one
Yeah.
that's
no,
Malaysian, yeah.
Yeah, the
Yeah.
Malaysian.
the one where and that was actually, they have a tiered service for, but the problem is that I believe every GE engine collects about terabyte of data
Exactly.
per day or
And
flight.
what they do is they store it locally.
Locally.
When the plane stops, then they actually upload it on the ground.
But you know what also happens? If the service, or if say United,
Yeah.
doesn't connect and pull the data
Yeah.
out, that gets wiped
Then it
out.
gets wiped out.
But in Malaysia, it was even simpler. There was just location service, just to
But-
know where the
and
plane is.
So GE actually has the service that they do regardless of
Yeah.
whether the Malaysia Airlines pays or not.
Okay.
And that was that thing that they were able to sort of find
Yeah.
those circles where they potential.
So I was
sector.
shocked that from the plane, you don't send
No
that
real time.
information. Real-time information not there.
But they don't send even the airplane real-time information. They
Right.
use radar pings to.
Correct.
To
So we were trying to pitch the maintenance to Airbus, and this guy said, you don't send information real time.
Connected to that,
Yeah.
in Pratt and Whitney laboratories, I forgot, they don't even sell engines nowadays. They went for the Microsoft model to kind of lease
Yeah.
engine, because you are using it, we are checking everything, and there's an upgrade coming or something.
Yeah, so they're now working with 5G. I think they're trying to change the
So
game.
going back to the business opportunity,
Yeah.
clear here, you found a very interesting niche
Yeah.
where the equipment manufacturer, I guess through laziness or whatever, they were not doing that themselves proactively.
Yeah.
So Wipro come in and offered them this as a service using
Yeah.
their own platform. So, but it points to a challenge, right? If the industry, it's a lot of money, like say oil refineries,
Yeah.
and they are technologically sophisticated,
Right.
they will have their own systems. And so to hire a service like this from a third party may be of no interest. Or the challenge for a third party like you or whatever is to come in and say, I can come in and do your business better than you do it and
Yeah.
save you money and
Yeah.
give me subscription fee or membership fee or whatever, monthly fee, and I'll run your factory or whatever better than you can run it yourself. That sounds like a high threshold. I mean,
Again, as I said that, even you look at oil and gas industry, there are two types of, installations. Some of them are the high-end installations which have the SCADA systems and all this in place, right? So what you're saying, you're right. In those situations, adding value is almost impossible. But there are a lot of other oil fields where SCADA does not make sense because it's an expensive system.
low tech. Yeah.
Low tech. So those guys are lying there. They don't have any information on those machines. That's why again you go there and say, I instrument. I give you because now they have to drive trucks over there and try to figure out what is the level and all that. So those things. So
But that's
you're right. So there is a dichotomy. In some ends, it's very difficult to add value because they know it. They're doing it for a long time. In the other end, there is opportunity. That's why you come in.
If you go too low end, then again, there is no point because they don't have ability to pay. They don't
That's
have-
correct.
So there's maybe
You have to find out the right niche.
Very
And yeah, right.
niches.
Very true. And also, even for the SCADA, the only other place where I see you can add value is because of, as I said, they have diverse systems. Like for example, there are 10 different types of MES systems that are used in the system, and they don't talk to each other. So then you can go there and say, I can actually aggregate the value, give you.
But that's a very expensive proposition if you have to go in there and act as a translator among
No, not really.
custom systems.
So, not really,
custom
because,
systems.
so for example, we have translators for leading MES systems. So what I can do is, I can put my adapter on the MES system, and from that I can get the data. And once I get the data, then I can have JSON format I can put into cloud, right?
Yeah.
So if you have non-standard MES system, difficult. But for the top 3 or 4, we have adapters. So if you have historians and there, I just put the adapter, pull the data out of there and create a dashboard for you and do analytics on top.
So another example is the smart grid, right? I mean, and because of microgrids, right? You cannot, they cannot, PSE&G has a huge problem if you put the solar panels on your roof and you become a source of energy, right? So either you have to do it through them, or if you do it independently, then they can't handle it. So the idea would be then to have a Wipro-like entity which will instrument your microgrid and
Yes, and
tie
then,
it into
yeah, and tie it.
there.
So most of the times I see the opportunities in the things that they're very sophisticated, but they're in silos. So then you aggregate across the silos, and that's how we provide value in many cases. We also do this is another real thing. That is, we do Internet of Clean. So this is a hygiene company in the US, and so they want to monitor the usage of various equipment, the hygiene, all the liquid, dishwashing liquids, and all kinds of liquids. What is the level of that, and based on that they can do pre-fill the consumables, if you will. So this is again a remote monitoring and of they call it Internet of Clean. So this is for cleaning supplies, and equipment manufacturers. So again, if you are paying me 400 million, I'll take it.
Yeah, sure. No,
I don't say no.
I just love the title.
They come up with their own name, right?
Yeah.
So it's interesting. So again, I just want to say a little bit about digital twin. So digital twin is becoming a very common terminology in the manufacturing industry. So what digital twin is, there is a physical assets, and it could be machine, could be different types of machines, and you monitor the machines and you create a logical instance of that in the cloud. So basically, you monitor the physical asset, all the data comes in, ingest the data, you aggregate the data, you run some modeling things here, and based on it, you do the analysis, and then you feed it back to the control of the physical asset. So creating a twin of the physical asset. I'll give some, and digital twin is very useful in multiple cases. So whether do product design, product monitoring, product operation, or product maintenance. So I'll give you an example so that you understand what we're talking about. So again, I'm coming back to the JCB thing. So there's a physical asset, and digital twin is a digital model of the physical asset that mimics the behavior and operation of the physical asset. So this is an example. Okay, so this is a physical asset, excavating somewhere in some part of the world. So now what happens, since it's instrumented, I'm getting all the operational parameters. I'm getting the altitude, engine running bands, 1 through 7, engine running hours, what is the current, the temperature, battery voltage, fuel level, everything I'm getting, and then I'm actually have a logical instance of that, which is exactly the physical thing. I can go down to this particular, say, how much it has been eroded, or what is the temperature. I can see that on the logical thing. So it's like for example, I want to see the external battery, how the battery voltage changing on that machine over there in India deployed. You could see that actually how the battery voltage is changing. So basically, you are seeing the physical asset not being there physically. And how does it help? Okay, it helps in the following way. Okay, first of all, it can be monitored and controlled from anywhere in the cloud. And so this is where, so you have the physical asset deployed in India, and you are doing the operations out of UK. So this is again very common thing. What happens is we work in a Nordic company. So they had their equipment in Saudi Arabia, in Chile, in Russia, but all their experts, they're in the Nordics, in Helsinki or Stockholm. So now what happens, if something goes wrong in Saudi Arabia or Russia, they don't want to fly. So they're getting all the data, they're analyzing the data in digital twin and say, well, probably, and they can go down, diagnose what the problem is, and then tell the guy over there in the field that, hey, go exactly look for that and fix it. So this is like, centralized users of the expertise, and then tell the people on the field that is what you have to do. You don't have to fly anybody out there. So that's like one use case of digital twin. So
this is what I need. This is exactly what I need.
The
twin. I need a twin.
You need a twin. So we need a digital twin of you?
Yes, that's good.
That is impossible.
I'm okay with that.
The digital twin of...
You already have twins.
But they're not of me. That's I can send them, I'm okay with that. Just the outcome will be quite, the model is wrong. It's a big failure in the model.
So this is like we take an excavator, we look at all the parts, and then we do the modeling. Remember I talked about the asset modeling part. Now we do the excavator that has hydraulics, transmission, engine, controls, electrical, go to the next level of details, engine, fuel injection, fuel pump, battery. For each one of them I stored the time series data, and I can have exactly visual. We have a 3D model so that once you bring up the digital twin, say I want to see the digital twin of, not Ivan, but digital twin of this machine in Rajasthan. It shows up exactly, you can see what is the temperature, how it looks like, what's going on, so you can see it completely visually. And type of use cases, again, in remote monitoring, of course, you can...
So when you do this model, do you need an exact hydraulic model and things like that?
So this is...
Who supplies that to you?
This is the interesting part. So there are two ways you can do it. One is, you talk to the vendor. You say that, well, for your machine, and many of these guys, like all the car manufacturers, Mercedes-Benz, BMW, all they have 3D model of their cars or whatever, right? Even JCB, they have 3D model of their equipment. So we just get the 3D model, and after that, we can ingest the model into a system, create a logical view, and then do everything based on that. So
the
3D model I get from
model
you.
you will get, but will they share with you the gearbox
No.
model, for example?
No, so that is where, see what happens now, the question is, you are going to next level, okay, come to that. Basically,
But
you're
the physical model may be relatively easy
Yeah.
within copyrights and industrial property,
Correct.
but much more complicated
Yeah.
is behavioral models.
Correct.
You know, if you run this gearbox at this RPM, you know,
For 3
How
minutes,
does it
it's
perform?
gonna
Yeah.
call,
Correct.
yeah.
so good
6 months
question.
from now, it's gonna
Yeah.
break, right?
Good question. So this is where we are. I'll give you an example of what we have done. So this is a remote optimization. Okay. So this is a problem. So this guy, asset is in the field, somebody operating it, and you get the real-time data, and he has no idea that the productivity can be improved. But what happens as I get the data? So this is where the predefined models comes into play. The model, either I can get it from the vendor, or the vendor doesn't want to share. Sometimes what happens is they say, well, I'll give you the model, but not the details. I'll just give you the, so black box, you can have inputs and outputs. Sometimes predefined models are created by statistical model, that I get the data. It's like I treat this as a black box. And then based on the statistical data, I create a statistical model. Or there could be engineering models. Some of they have engineering models, they'll give it to you. Like oil and gas industry, some of them will give you the engineering models for the drill, and some of them will not. Thus, I'll give you a black box. Some of them will say, oh, you create your own model to the statistical analysis. So when you do that, then at some point when you do the analysis, you can say, well, this guy is operating, right? He has no clue, and suddenly comes up that on the dashboard that your productivity is low. Do you want to improve the productivity? Yes. And then what I do is, from the digital twin, I actually tell him what are the options he has. And I can say, well, you could adjust the RPM, you could adjust the bucket cut depth, and here current productivity is 3.63, you can boost it up to 29, you can boost it to 30.77. So I can give you the advice on how you can do that. So that's again, based on the current operation, based on running the model, I can figure out that how I can improve the productivity, and give him the advice. But again, this is not a very clear-cut answer where you get the model. Some cases you do it statistically, some cases you get the model, some cases you get black box.
also, how do you make the audit? I mean, you may hope that improves, but maybe you're missing something, or the model is not accurate, or there is misinformation from the field, and instead of improving, you're degrading.
Correct.
So there has to be some kind of supervisory
Correct.
auditing going on.
Exactly right. So again, really good question. So what happens is, now you give the advice, right? So how do you know that it's going to improve? The thing is, I do continuous monitoring, right? I continuously getting the data. From the data, I know that whether the KPI that I'm trying to improve, whether that is improving or not. And then sometimes what happens is we start off with a model which is our first engineering model, but engineering model makes a lot of assumptions. So once you run it, you realize that hey, it's not really matching, but there's some deviation. So based on the deviation, then you change the model, you adapt the model so that it's more realistic. And you don't do it based on a single instance, but based on hundred thousands of machines are getting the data. And against that model you're checking, you see the deviation, you do statistical analysis, figure out, that delta probably has to be changed into the model so that it can predict it more accurately.
Do you know if there is any standardization effort for the exchange of community data for the manufacturing? Because I can see, for example, on the modeling, you take one factory, one car, and every year there is a new model. You're going to have to update your models. You're going to have to make different one for the different car. And right now, these are proprietary protocols.
No, are you talking about what protocol? The protocols or the model? What?
Any kind of standardization as far
No,
as
protocols is standardized. As I said that in protocol, I can pull the data from any machine, like Canvas, Modbus, those kind of protocols. Then I standardize it. I extract the data, use JSON format, I use TCP, IP, MQTT, and then data is mine.
not communication, the content of the data. Is that something standardized? Say.
Oh, content of the data. Content of the data.
Yes.
Yeah, content of the data. Yes. When they use Modbus, so when they use they basically when you work with the vendor, work with the client, they give us the.
But every client gives its own. Is there like a worldwide body that says everybody who has RPMs has to
So
use
it's
this
tricky.
format?
It's tricky. For example, the lobbying power of Siemens and ABB and these guys are so much. is very difficult to standardize. If there are multiple people, these guys are powerhouses. And each one of them, believe it or not, Siemens has something called MindSphere. Siemens is my IoT platform is MindSphere. All my machines will run on MindSphere. ABB says, I have ABB Reality. All my things run on ABB. The Honeywell says, I have a Honeywell Sentience. You put everything on Sentience. I said, guys, but how do they interoperate?
So in the cellular industry, because the incredible value add of interoperability,
Yeah.
Meaning you buy your handset,
Yeah.
and you know that no matter what base station you happen to land close to is going to interoperate.
Yeah.
So standards have been paramount and keystone to enable a wide acceptance through interoperability.
Good point.
Now, in a factory where you may buy an entire factory from a single vendor like Siemens, that is not for interoperability, and the vendor has built-in interest to
Built-in
close
interest
shop.
to keep it, that's true.
So
So
these
that's-
notions of
And also
Open,
you're right.
interoperable.
And so in the telecom industry, what happens is B2C. End of the day, you and I who are using the phones, we actually dictate. Manufacturing, these are more B2B. The Siemens is selling it to Georgia Pacific, selling it to Eastman. There's no end user. There's a factory they are deciding what they want to do. And that's why the pressure of standardization is fairly less. And as you rightly pointed out, a company probably buy all the equipment from Siemens. So it's like a captive house, closed shop. And so that motivation is less. But some of them are now asking, hey, I have Siemens equipment, but also have some from Honeywell. But that is slowly coming, but not as fast as the telecom industry because of pressure of end users. And that pressure is kind of less in the manufacturing sector. Yeah, that's why it's a challenge. And that, it's a good and bad. It's good for people like us, system integrator, for every time it's a new job for us, right? 10 million, 15 million, I'll take it, right? The moment it becomes commoditized, then, the custom development is not necessary. And the other thing that happens, sometimes the asset is not connected. Like if it's not connected, so this is where we can create various models and push the engineering models into the, so this is like an edge concept again. So the model is pushed, as opposed to doing a calculation here, I push the model into the car, into the tractor, and then you allow the operator to look productivity, and I say, well, I want to optimize it, and it runs in the background recommendation model and gives the option right itself. So there's nothing in the cloud, we cut it out. So that's another possibility. If it's like in a shape or something where the chances are that you may not be connected to the cloud, in which case I do the model in the cloud but push it into the edge and execute it in the edge. So the digital twin has been also is still in infancy in the sense that, again coming back to digital twin, if you go to Siemens knows the hell out of their equipment. So they can go to very little details of the things that you cannot. They'll not expose all the details to you. They can create a much better digital twin than anybody else can. So that's their vested interest. So the people are trying to say, can I sort of estimate what the model will look like, and based on that I take an action. So, and also this is also used for things like, we can do things like geofencing. So this is another thing that we have done. So because of, so the machine is there, and so you want to simulate a geofencing alert. So you say yes. So what happens is, the machine is there on the cloud, and you're saying that, well, I want to make sure the machine does not go out of this area. So you can define the route of the area on the virtual machine, not on the physical asset. And then you want to test it out. You want to take it out of that geofence, and there's an emergency alert. So basically you simulate that, well, if I have this geofence, goes out, alert is generated, and then you can actually push the configuration into the physical asset. So pretty much like, I remember that in Lucent, when we were coming up with the 3G base stations, the 3G base stations which are sold in the US were far more expensive, and I think, remember that Lucent did a deal with Reliance in India. And Reliance wanted an extremely cheap price. So what Lucent did was they had many features, but they masked many features and exposed only a few. So in the sense that you don't want to do a new set of machines, the same machine, but configurations were masked. So it's pretty much like some of the things that you do here are called configuration over there, that is already configured, but you can enable some configurations. And sometimes when you completely change it, you do firmware upgrade over there. So this is like type of things you can simulate before you even try it out. And another thing that we do is, last thing in the space is on the maintenance part, predictive maintenance. So basically you try to give the remaining useful life of a component, engine, hydraulic system, transmission, brake, etc. So basically you have the, So what happens in this case is, you have the digital twin of the physical asset. So remember that this is exactly giving you what the physical asset looks like. Now you want to simulate that if I run it for another 10 days or 15 days at this rate, is it going to break down? So you can simulate that, and based on that it's going to break down. So you give the maintenance alert, predictive maintenance alert to the end user. So that's how you can do a digital twin can be applied. I just want to, there are a lot of things, but I don't want to take up too much time. I just want to give you something that we're doing in safety.
I have a question.
Yeah.
So when you do the twin, how good does the model have to be in order for it to be useful? Because you can have various levels of abstraction. If you don't model certain things, you can't model safety or,
Very true. So I'll say that digital twin is still in its infancy. It has not matured enough. So industry is talking about it, they see the value, but all the questions that you guys pose are very, very real. They talk to clients say, I don't want to give you the model. That's my proprietary thing. In which case you try to estimate the model.
But they might not have it, but you can use machine learning to
Yes.
extract a model.
So there is people say, well, why can't I use neural networks or other to sort of estimate the model as close as I can?
Well, but then we may be overloading. I mean, I know there's a lot of hype in AI ML, but let's think through it very quickly, right? Suppose I want to do a very simple data-driven learning from ball-bearing failure model.
Yeah.
Well, I need to set up a lab
Yeah.
and have 1,000 ball bearings and run them until they fail.
Yeah.
Oh, that's a very expensive and lengthy proposition. Then I have to repeat that for every critical component. I mean, it's not as simple as just
Not as simple.
saying
Correct.
AI ML will learn.
Correct. So that is why, but many of the customers, they're willing to give you a model. They say, well, they already have the model, right?
The designer maybe.
The designer,
bottom up, they know.
see what oil and gas industry, I'll give you an example. The researchers, the PhDs guys, these guys are using very sophisticated models to predict, where there'll be oil and what kind of drilling has to happen and all these things, right? They do all the modeling, finally they make the design, and when the drilling happens, they move on to the next place, right? When the actual drilling happens, the operator comes up, the operator has no clue. He's looking at things, production is falling, let me just crank it up, and they have no clue what the hell is going on. But if somebody can take this model that the R&D engineers use and give it to the operator, and you run the physical data on that and say, something, if you crank if you reduce the pressure, then your production is going to go up. And by so much, if you can visualize it, then it makes a difference. So many times the models, they're willing to share the models because models are not used other than by the R&D engineers. Now if I can leverage it for the operators, they will give it to you. So that's, again, it's a concept and it's evolving. I think it will change over time.
So we see the potential and we see the challenges. So in the real world, are you seeing this still in the very flat part of the exponential, or you see that starting to take off, or how do you see this in the real world of revenue?
I'm very positive it's starting to take off. It will take a little time. The early adopters are just dipping their feet in there, but I know that we are going in a big way. Gartners they're all predicting that it's going to take off.
So today, what is the world revenue on these segments, and what is the growth rate for say industry 2.0 related?
So industry 4.0 related.
Industry 4.0.
Industry 4.0 today, the Industry 4.2, so it's very difficult. So if you just say that all the latest technology and all the applications, that kind of few companies are using it. few, very few. OEMs are ahead. Like for example, ABB. I know ABB, Siemens, Honeywell. So they are ahead. They are creating all those technologies, and slowly they're trying to push it. And what ABB is doing, I'll give you an example. ABB, say they make all these switch gears and stuff like that for electrical grids, right? So previously they used to sell the equipment. So one-time sale, $1 million, whatever, $5 million, $10 million, and collect the money, and that's it. Today, we are developing a software for ABB. So ABB is not only giving you the equipment, but also give you software. What the software will do? Software will monitor your equipment. And software will tell you when equipment is going to fail, and Siemens or ABB will know that they have to send their experts there. They have to send their parts there. So it's creating a sustainable revenue model for ABB. So they're actually, so the digital twin and some of these things are slowly coming in. OEMs are ahead of the game because they want to push it from their interests. And slowly, but manufacturing clients we talk to, like large US steel plants and all that, these guys are so sluggish, and it takes time. I keep telling them that you can do proof of concept 100K, 200K, but that's their bread and butter. They all the things, they don't want to risk it all. They want to get a confidence level before they get in. So it's going to take off, but still, we thought it was going to take off this year, but did not. So we are hopeful. We are investing heavily on digital twin and others, so I think they will actually come up. Expecting. So only here I don't want to go into details, but only thing I want to say that I talked of worker safety, and these are the real statistics in terms of, this is actually a very staggering number. 222 billion per year is spent in the US by employees on workplace injury and illness. So if you can prevent that, even if it's a small part, that's a big deal. And some of the things, as I said, that deployment of factory sites. This is the case that crane operators over there, and there's a worker on the ground, inattentive and carrying heavy stuff, something can fall. So we have actually instrumental system. We did with a steel plant. We actually put a camera. We actually took the picture. We create a dashboard for the crane operator. So crane operator knows that there is somebody downstairs, and he can have two-way communication with the person on the ground. Or even if this guy is inattentive, he could have a helmet which will buzz. So basically making him aware that there's a problem and be aware. Crane operator knows, this guy knows, safe. Many times the people that walk into an area, they feel like, but they cannot because some restricted areas. So that is where again, you have to put helmets and systems in place so that only the allowed people can get in.
So I'm sure you're familiar, 5G vendors and even service providers, they all talk up this story.
Yeah.
And being the skeptic guy that I am,
Yeah.
I sometimes wonder,
Yeah.
in the factory floor,
Yeah.
where everything is inside a closed area,
Yeah.
do they really need 5G monthly
Good question.
membership with Vodafone?
Good question.
Or could they just do proprietary Wi-Fi?
Good question. Again, that is my question. So this is what when I was told that Sanjoy, you take your intelligent factory story and put 5G in there. I said, well, do I need 5G? First question. Do I need? Because I can do most of the things today without 5G. Then I have to come up with use cases where ultra low latency of 5G is necessary, or extremely high bandwidth is necessary. So I have to come up with cases like that. But for most of the cases, given that industry is slow itself, getting these basic things up and running is the challenge. Now pushing 5G is like, I think it will be, you really have to make a case for it.
But some of now to take the other side, some of the guys we've heard from Bosch, but I don't know whether these are people who have a personal interest career-wise or whatever on 5G IoT, that they would say, oh, Wi-Fi, it just doesn't cut it. It's not reliable, it's not safe. But I can imagine industrial grade, ISO 100, properly installed, probably 95%
90% of work is done. Even with the only thing that the challenge happens with Wi-Fi is the location, because so for example you have to locate somebody coming to a moving conveyor belt, then location becomes an issue. But
5G is not going to give you any better location.
5G
No, I was just going to say, there's nothing in
5G is not going to solve the problem.
So the only argument for physical control of the space, right? I mean, if you have physical control of the space, then there is really
You're the
very
facto
hard to
owner.
argue.
But in the,
However, if you have open spaces like, say, a port or, you know, large construction site, if I come in with my Wi-Fi phone and start watching,
Oh, if
know,
you are malicious people that can make
malicious or even in innocent, like, you know, break and I'm watching Netflix. 5 of us are watching Netflix or a break.
break
and
down
we-
the Wi-Fi.
Exactly.
Yeah, right.
but the
Coverage area might be a bit larger first.
Well, Wi-Fi comes in
5G is not
if
that.
you're talking wide area coverage.
Exactly.
If we're talking, you know, truck fleet management or ambulance management over a wide area, then of course you're not going to start putting Wi-Fi everywhere.
No, but even in the areas where you say, okay, you know, large in terms of mile by mile or something like that, it gets a little bit tricky to, because otherwise they have to start planning. But you know, arguably the coverage of 5G is not going to be much wider than the
it's
Wi-Fi.
struggling.
I mean, for all these applications, 5G is good enough.
Good enough.
Yeah, it is wider, I mean, if you do roadway automation.
And
it
that's
is
where you want the wide area coverage, which
Right,
has
but-
always been
yeah.
king for
But
Yeah,
for
but
a-
not a factory setting.
For
Yeah.
in-building factory, I find it hard to believe that this is.
In factory, latency is so low. They're all wired, and the latency is the claim to fame is the operation technical latency is extremely low.
I have
You
to
know,
agree,
how
I mean,
can
they,
you-
they cancel my pension, but
Yeah.
I just don't see the need for it. If you're
Maybe
inside a
factory.
factory, inside an enterprise.
Yeah.
So your CTO is giving a lecture about this.
No, but I mean, listen, I have a very simple answer. It's going to be 5G as long as the price of 5G's infrastructure is the same as Wi-Fi, right?
Well,
If
but
you make it that
it's gonna
low,
be a long
then
time.
you can argue. It makes
So,
sense.
so this question has two parts. Is it ever going to be as slow as
No,
Wi-Fi?
I don't believe it.
And if it did get as slow as Wi-Fi, then these existing vendors will go out of business.
What's the price of that?
Yeah, I agree.
They cannot survive on those
I
prices.
agree.
What is the cost of having both? I mean, every cell phone has both Wi-Fi and
It's not the cell phone.
5G.
It's all
I
the
know,
network
but-
and the protocols.
Yeah.
And
No, but
the-
I mean, intriguing concept is the idea of Bosch owning a 5G system in their factory, right? Which is allowed in Europe.
You can do proprietary,
Proprietary
5G,
or-
right?
or
Like
private
enterprise,
5G.
private
Yes.
in maybe shared spectrum.
Exactly.
The only question then is, if it's a box, it has an antenna.
Yeah.
No, that's Wi-Fi.
Does it
That's
hit
what
a
I'm
lower
saying.
price point because it says 5G or Wi-Fi?
No, I could have the Ethernet on the standard cabling, right?
No, but it's actually even worse because, you know, you can't, these days, if you buy a standard 5G equipment, you can't work without all the back-end baggage, right? Which is
Yeah, that's
extremely
changing.
heavy.
That's changing fast.
It is, they have to. There is no way. I mean, nobody wants to.
So to
But
answer
still,
your
at the
question,
moment-
I'm
I'm on the same page.
really struggling, and so I just I want to say that we created this helmet so gas leakage, proximity to hazard, fatigue, man down, buzzer, so all the things are there. So creating a system on the helmet. What we've done is this whole thing is like attachment. You take a standard helmet and attach it to that, and you get all the benefits. So that's how building the system and taking it to a market for the safety.
How heavy is this
Helmet?
attachment? How heavy is this attachment?
No, it's very small because it does have the sensors and this is extremely small. So we have.
those sensors if you want to
Yeah.
play
The
with.
sensor technology is getting extremely
It's-
advanced.
yeah,
It's in your iPhone. There is altimeter, there is
Everything.
speedometer, there is GPS, there's all sorts
Everything
of
is
things.
done in a small space, and so
Yeah.
it's a small attachment and also very inexpensive. So you can just
Yeah.
attach it.
Well, the main concern when we talk to first responders, that they say that every vendor would try to put something on their body. So eventually they have to put a lot of things on the belt. So eventually, some policemen, when they get old, they have problem with the waist, not with some other problem. So this is my concern, actually.
No, basically tell them that the argument in those cases will be that, so let's see, so what are the things that you try, before talking about what equipment you put, let's see what problem you're trying to solve. You're trying to solve 1, 2, 3, 4, 5.
Yeah.
If I can solve 1, 2, 3, 4, 5 with an attachment like this, will you take it?
Well, but the problem is, you might eventually have one attachment solving just the one problem.
No,
Eventually you
no,
have-
that's my job. So I'll create an attachment, small enough, that will solve all the 5 problems that you have. So today the sensors are there. Most of the sensors can do, this so small and so much functional, they could do a lot in that small space.
So is Wipro concentrating mostly on the software aspects of the platform and the models, or are you guys also designing and manufacturing the gateways, or even eventually the sensors and data gathering?
No, data gathering we do. There were mostly the multi-protocol gateway and things like that. But the hardware comes from Dell.
So yeah,
they-
so it's a general purpose.
General purpose machine that
servers
we
with your own
put
software.
we basically put our firmware on there and we going there.
Okay.
We do have the capability of going to, say, if we are trying to create that sensors and firmware and things like that, we do have a part of Wipro which does all those hardware development called WIN. So we have been doing the hydraulics for aircrafts and all that. So there is a group which does that hardware. So necessary that we do that, but most of the time we are taking from partners.
And who's your biggest competitor? Is it IBM trying to get into the game with the?
Accenture.
Accenture.
Yeah, Accenture is a complete with us. So IBM is also
So
there.
the old-fashioned system integrators.
Old present system integrators, yeah. And so this so we are trying to put even the AI just to show that tracking the eyes and feel this guy is falling asleep, and then again hazard and things like that. So the short question is there is system.
So here's a good example. I mean, it looks very cool and very impressive. But when push comes to shove,
Yeah.
it has to be extremely reliable, right? So,
Yeah.
so if you have an operator in front of a machine that is producing millions of dollars per minute,
Yeah.
and if there is a mistake and
Correct.
you stop the operator, on the one hand, maybe you stop an
Correct.
accident, on
Correct.
the other hand, you cause $20
So
million
you're right,
So-
absolutely right. So that's why you don't depend on just one. So we are putting multiple. For example, there is some wristband also, which actually taking some of the So you take 2 or 3 different dimensions in which how long she has been working. Has she been working 4 hours or 14 hours? So you take 3 or 4 dimensions. If all of them are pointing to the direction that probably she's fatigued, she's fatigued.
And this is where your concept of before may become very relevant. Maybe it's not a robot, it does not have the authority to stop production, but maybe the cobot, it can raise alarm.
Raise alarm, the
ask
human
question,
yeah,
are you okay?
Yeah, are you okay? Yeah, exactly.
Yeah.
Yeah. So I don't know, I can probably stop and this, what else I want, this other thing I wanted to talk about was, so this is another thing which is working in the field. Very simple example though, this is a logistics example. We were working with the startup. The problem is tracking. I'll give you an example. I'm not going to details of how we do it. The tracking. So these are, you have the containers. Containers have various components, raw materials and things like that. The containers are shipped by the logistics guys and put it in the bay. That is 20 bays, they put the things over there. And from there go into a warehouse. And at some point you have to take it out of the warehouse and put it in the outgoing bay. So the tracking of the things from the suppliers to the manufacturing to finished goods to warehouse, and this whole process, people don't have full visibility.
But Amazon must be the kings on, because it sounds very similar to their package handling factories and distribution centers.
Amazon has done it. Amazon is probably the leader in the warehouse management, if you will. But many of the, for example, I can tell you that we are working with auto clients. So talking about GM, General Motors, right? And General Motors, they don't have a mechanism.
And Amazon is not offering as a service to run their warehouses?
It's more than the warehouse also. Like for example, from the suppliers are
Supply
sending
chain
all the
management.
components, right? And this containers are coming into their in bay of a warehouse, and from there going to the warehouse, and then many other suppliers are sending the things, and then it will go to a manufacturing facility, and then tracking all these things through the warehouse from the suppliers to logistics to the warehouse to the outbound thing. They don't have a solution. So that's where we're using, with the startup. This startup has actually done very good, and we're working with them. This is a very simple solution. Solution is not complex at all. This is the solution. Use the sensors. So they have purpose-built the sensors, which are 2 to 5 years lifetime of the sensors. You can slap on the sensors to any container. Okay, now they have something called zone sensor. What the zone means is like you have a huge 100,000 square feet warehouse. What you do is divide it into a graph paper XY, into zones. Each zone they have zone sensor. So they know that when something comes in, which zone it belongs to. And then they have the gateway through which they connect to the cloud. Very simple solution. But with that, all they're giving you, they're able to give you these things which has significant value. For example, they're okay. So location, condition, they also have external sensors like temperature, shock, vibration, humidity. For example, you can say, well, your in a pharmaceutical, say, well, your this serum which has been lying on the warehouse for the last 1 hour at this temperature, humidity. So, oh shit, this is the alarm, because if it's lying there for 2 hours, it's all gone and it's millions of dollars. So just fact that how long something has been dwelling at some place, how long, and those kind of things, and adding value to the business. Simple solution, nothing complicated, but it has tremendous amount of applications.
The supply chain is used most frequently as an example for blockchains.
The blockchain, yes.
Minus cryptocurrency. So the question is, did you run into an example where somebody is requesting blockchains?
We do, yes.
Okay.
We are basically, there is a RFP response that we are responding to, which is actually they want to track things through the supply chain, and they want the information to be immutable, that nobody can play with it.
It's becoming very important in the food traceability.
Food traceability?
So if meat is bad, where it came from.
Yep.
Walmart, I think, is starting to implement
The IBM and Walmart, and in fact, we actually proposed something called strawberry to jam, that is from the field,
Yeah.
all the jam, how you track it.
Yeah.
And IBM is doing something with Walmart and some of the other people. Yeah.
You're using a hyperledger based?
Yes, well, we have a platform where we being system integrator, we have a platform where we know customers will ask for many things. So we have a platform, abstracted the layer. If you want Hyperledger, Hyperledger. If you want
Quora.
Ethereum, you get Ethereum. Quora, you can Quora. So we give you a way to play around, and based on what you want to choose, you can choose.
So I'm not an expert, but I've read that there is a throughput problem with blockchains.
Yes, it is.
So if you're now
Yeah.
going to put every produce in a supermarket, in all supermarkets, I mean, then
It's a logical
going to collapse, right? It's non-stop.
Absolutely.
But
And-
not always distributed.
So there are two things that are happening. Two
Yeah,
things.
consensus is the problem. not-
Consensus is a problem. If it's not distributed consensus, but
Then everything works.
then it works. If
Yeah,
it's,
two things.
So maybe I talk to you later. I don't understand the difference.
So the two things are happening. One is people are trying to solve the scalability problem because this is like too much of information. The other thing people are doing that, can you be smart in terms of what information we store in the blockchain? Every damn thing I don't have to store in the blockchain. Can I be smart? Can I have some business rules based on which are most critical? And only that information is stored in the blockchain.
Okay.
So that way you reduce either the amount of data that goes into the blockchain or try to scale the infrastructure in some way, distributed.
The way I understand it is the problem is with the number of transactions per second.
Yeah.
If every time a produce or ingredient
Yeah.
it changes location or owner,
Yeah.
it's a transaction. Then the number of transactions must be humongous if
So-
you wanted to have every produce every.
So this is the AWS, the Amazon Web Services. They recently had the reInvent, which is the conference in which they announced the services. They announced a service called on blockchain.
Yeah.
So this is they call it QLDB, or this is like the distributed ledger services. They just announced the service, which I believe that if it's on Amazon infrastructure, they will be able to scale horizontally with the technology. But again, that remains to be proven. This system.
it goes between Bitcoin, for example, that can do 2,015 transactions for 10 minutes,
So that's not.
which is horrible, to Hyperledger or sorted systems that can do the same as a Visa or MasterCard, 10,000 transactions per second. So there's a
So you're
big
telling me
range.
there are already solutions for throughput out there? that
Yes, but
I can learn
there is a
about.
price to pay for throughput as well.
Okay.
So I just, since you brought out blockchain, then I'll give you one example that slightly, this is again slowly gaining interest in terms of how do you use blockchain for a different purpose. For we call it intelligent asset. So anytime, so for example, you want to rent out an equipment. For example, here you are renting out this thing, so somebody has to monitor it and find out if it needs service, then who is the best, who can provide you the best service for this particular equipment, who can I rent it to, all these questions crop up. Now, what we have been doing it, we are doing making the machines intelligent, in the sense that why this is important is, so far IoT enabled downtime, objective was to reduce the downtime, that I want to make sure the assets are down less time. That is, if I have a machine, most of the time it should be used. It should not be unused most of the time. Now the question is, can I maximize the utilization of that? If I'm a rental company, I'd like to make sure my trucks are always rented. If I'm a rental equipment, I want to make my equipment always rented. Can we make that happen? So that is where we're using blockchain. So this is I'll give you an example. So this is an autonomous asset rental. So this is like an asset which is available for rental, sends information to the blockchain. So I say, well, I'm available, and it sends the information to the rental marketplace. And you as an asset owner set the condition that, hey, if you bid less than $10, I'm not $10 an hour, I'm not going to take it. So this is the range in which you have to bid. You have to, within 20 kilometers of where I am, you have to have this condition, set the conditions. And then this guy announces, I'm available, and you bid for it, rental marketplace. And then all the people who are a leasee, who is looking for the asset, they can take part in the auction for the asset usage. So there are multiple people who will say, well, I want to lease you, I want to lease you. And finally, somebody will win the bid. And all happening through the smart contract. So marketplace does the price negotiation, chooses the leasee by running the auction for the asset, and you say, well, I'm rented. So here, no human intervention, the machine itself makes it available on the rental place, and through the smart contract, it's get rented.
So this begs the question, sorry to keep, but it's a very timely and urgent question.
Yeah.
The whole sharing economy, Uber, Airbnb, all of these guys would die if this happens. Because this is Uber without Uber.
Uber without
You
Uber.
just connect the car owner with the passenger without having to go through Uber side. It's totally autonomous.
Yes, totally autonomous.
So either they're jumping on it or they want to kill it.
I don't know, because we just talked to one of the analysts, and this guy said, talk to John Deere, because they might be. But again, broader question is like, exactly, is Uber without Uber? Because this guy says, I am available, I'll just put myself up. You don't need Uber. And people are, auctioning is completely disintermediating even Uber.
And the question would be how your system would do better than Uber.
Huh?
How your system would do
You don't
better.
pay Uber the 10-20%, they skim off the top, number one.
Yeah.
Well, but you need resources to run the system, no?
What resources? What do you get from Uber? When you call for a Uber
Well,
taxi?
the marketplace, the virtual marketplace, whatever it is.
So,
Is that a
Okay.
server or something?
But that's
distributed
the whole
ledger
idea of
does
blockchain, right? So
It's a
blockchain,
distributed
smart
ledger.
contracts
This
must be
is
running
ledger,
in some
then
distributed server.
block-
Somebody has to own those servers, and
Yes.
somebody has to be paid by
No,
it.
but I mean,
Yeah.
But-
servers can, this is a server, right? I mean, with a proper.
So maybe somehow the money gets paid back to Amazon Cloud or somebody, but
Yeah, so
but it's Uber without having to pay to Uber.
without having to pay to Uber. Yeah. This
And
is
Uber takes like 25% of every ride.
Pay to Amazon.
Huh?
Then someone
No,
has
no,
to pay
but-
to Amazon if you.
This is a machine.
Well, then how much data you need to save on this machine?
Well, this is growing much faster than you think. Remember, 64 kilobytes is all the memory everybody.
So, but
right?
you bring an interesting point, which is there is something happening in the cloud, which
Yeah.
now Uber, now is it really worth the 20% that Uber takes out of every ride?
Mhm.
Maybe it's worth much
much less.
And if you have the technology to do it without the central corporation,
So if
that
I can
owns the
offer what
platform-
Uber is offering, at a significantly lower price point, I'll do it.
Well, maybe some other similar company can do the same thing.
No, but
No,
you're
no.
missing the point.
Sure.
There is no company. That's the whole, the idea is that you have a car, I need to go somewhere,
Mhm.
and there is a software running distributed,
Yeah,
where
but-
it connects you with me, without any central controller
Yeah, but
that
you
that
need
I have to
some,
pay commission to.
you need some
Economic
computational
incentives for
resources.
somebody to maintain the service.
There is some software
Yeah.
running that has to be maintained.
Bitcoin is the best
Yeah.
example.
Bitcoin is your best example. Right? There is no.
Somebody's running Bitcoin, right? Now, but so
Nobody's
they
paying
do
for
it
running
by
Bitcoin,
the
But those
guys who
miners
are mining, they're getting their
Yeah,
Oh,
the
reward.
miners are, you're paying the miners, right?
Yeah.
to do.
Yes,
the
but they
money.
are not taking a commission out of every transaction you do with Bitcoin.
Small.
It's
Yeah,
small,
well,
it's very small.
It's a very
Yeah.
It's a
small.
very,
But
very, it's
in the
significant.
Uber
It's
case,
not, it's not 20% on
Yeah.
any
It's a much
ride,
smaller.
right? It's much smaller.
You're right that somebody has to pay for it, but the actual markup is so much, that can be significant.
and then besides the cost reduction, that could be a huge factor.
Right.
All of the user's data and the car
Yeah.
owners or,
Yeah.
or the driver's
Yeah.
data
That's
is
good
all
Uber.
owned by Uber.
All over
They can do whatever
Yeah.
they want with that data.
That's
In
again
this
the-
model,
this
there is no
problem is
central
no
data
central
owner.
database. Yeah.
But the big part of Uber is creating a trustworthy interface for.
Blockchain.
No, it's not only about money trust, but it's also a question of do you trust the car?
No,
that's going-
remember then same question with Bitcoin. Should I trust Bitcoin? Right?
Yeah.
No, Bitcoin is plain money issues, right? But
But you have to trust, right?
You have
You're trusting the
to-
there's
system.
some level of trust.
No, but you have also,
But
as
you raise
part
a-
of this, you
but
can
you
have
raised a very
rating.
valid question.
Uber is
Can we
creating
create a
a-
similar trust
I
environment
agree,
in
but
a
you-
distributed
that's
fashion
very-
without any central agency?
That I think is hard, but often I think Uber's main value is not their transaction. The money transaction is trivial. Anyone knows how to do that. PayPal will do
Sure.
that for you. But the trust model by which the car is dispatched to you and you feel
No,
But it's very real. I mean, if something happens to you,
I'm not
you
saying that
think you
Uber
can
is-
find the
I'm
driver.
not saying Uber is very trustworthy. It's
No, but at least you
No,
have a
but I mean,
sense.
trustworthiness
that
of Uber is based on the score.
right, but it's
Which
marginally
is-
trustworthy compared to other options.
No, but I mean that, you
I
can
think
have
it's
that same
very
score
human,
here.
right? That you
No, but the
assume
same score
that
can exist
something
here.
goes wrong, you can find through Uber who the driver was,
Yeah, or Uber
all the
has-
information.
Uber has some
So-
But here you also have a ledger, so.
I'm not saying it's impossible. I think it's a valid point.
So according to Roy, you have to cancel anything that comes back with less than 4.5.
4.5, yes, I know, mine is
4.7.
4.5.
Oh, or the drivers. I mean,
Yeah,
Uber-
4.5 score, I'm not gonna
No,
take.
not getting into that car. There you go. So, but I think this is a very
It's
valid
an
question
interesting
whether
question,
the users are going to find
architecture,
the trust
Yeah, trust.
Yeah.
on a faceless
Yeah.
solution.
It doesn't exist in society.
But today, 4.5 on Uber is also users clicking
No, I
grades, it's not
I
Uber
believe that, but it's better.
checking his skills or reflexes.
It's better than standing in the middle of the road and grabbing.
No, but you can have 4.5 here also. I can have a same scoring mechanism.
No, but I think that is intangible, right? And if you use Uber, you have a sense that you can get back at the information.
Right, there's
Some level of-
and they're making some service guarantees of some sort.
Or at least they're keeping the identity of the drivers in their servers.
So that's
Listen.
what I say.
So trust is a huge. I mean, Bitcoin has been trying to displace banks, but trust
Yeah,
maybe
but
is the
that's-
reason that
That's a big
never
issue
quite
because
happens.
the actual transaction and its efficiency or its security is one thing, but the other is a
Yeah,
human.
the human trust. Yeah.
Yeah.
Even with driverless cars and all that, like. But anyway, so this is something which, just slowly we announced this in AWS reInvent, talked about the Intel assets, and there's some interest. We'll see that whether there's a market for it or not. So that's all.
Okay, so I think we are
Yeah,
at
so I,
15.
Sorry about asking all
That's
those
okay. No,
questions.
that's good. The interaction is important because, yeah. So I think so. So this is what we have been doing, and basically it's more of a. In the first half of my career, we tried to develop technology. The second half of my career, trying to see how we can use the technology to solve problems. So that's been an interesting journey.
So can you give us a little vignette of Wipro, how big it is? Is it?
Wipro, we are a $8 billion our revenue. So our market cap is about 30 billion.
Mhm.
And so we are about 180,000 people.
Oh wow!
We are in 66 countries.
Oh, it's huge.
So it's fairly large, yeah. So we have the manufacturing business, about $1 billion business, manufacturing. Then our largest business is finance and banking and finance, which is close to $3 billion business. And then we have consumer business unit, which is retail and some of these things, which is again second largest, which is about 2 billion. The high tech is another 1.5
It's
billion.
publicly traded company
Yeah, publicly traded.
based in.
This is
Asia?
they're based in Bangalore and based in Dallas,
Oh, okay.
Texas.
Wipro's founder is known as a unique reputation
Yeah.
compared to other IT guys.
He's, Wipro's founder, Ajim Premji, they come from, they used to have a family business of vegetable oil.
Oh, wow.
From vegetable oil, he transformed the company to an IT industry. And very unique part of his personality, he is, a significant part of our profit, goes to education. That is for educating the people across the globe. So this year he got conferred the highest award from the French government for, social.
This is not the guy who founded Amity University.
No.
No, okay.
This guy is quite unique.
Yeah.
Yeah.
He's a good, well-known guy. So this is where Ronaldo. So we have been asked to see that how we can do 5G in factory. So then I started thinking and tried to create some use cases. You see that where you use EMBB,
Yes,
MMDC, URLLC, then try to come up with use cases, cobots, latency, reliability. So we tried to do and doing some dabbling in there. We'll see.
So in your opinion, what are the opportunities of 5G?
Honestly, I still don't buy into it. We'll see. I haven't tried to sell it to anybody yet, so I don't know how the.
You haven't found
I haven't found the
killer app.
Killer app yet.
Okay.
So we'll see.
That's very candid.
No, but I think there is a echo chamber now of manufacturers and service providers all saying 5G, but it's not well justified yet.
No.
In academia, we've been very careful not to use the term 5G at
Yeah.
all, right? But-
Well,
but-
just like Verizon, Verizon.
No, I mean,
AT&T.
it's clearly like every generation of technology has some significance, but whether or not it's so big a difference and why it will replace all of Wi-Fi,
Yeah.
and these are wishful thinking.
Mhm.
Like a few years ago, people thought that Wi-Fi will die because it's unlicensed. They say, okay, move to licensed LTE, everything will be great. Now they say move to unlicensed LTE.
Yeah. Yeah.
There's very little value except for mobility. When you have mobility and wide area.
Wide area coverage.
Yeah, wide area coverage, mobility. I think that's the sweet
If
spot.
you have the combination of mobility and wide area coverage,
Yes.
then there are
Now
That's
you
the
need
sweet spot.
mobility, wide area coverage, and ultra high bandwidth requirements. So what app?
So one of the things is the video camera and all that stuff.
Self-driving cars.
Yeah, but the 5G has a very heavy weight to carry because not only needs to be wide area and coverage, that cannot be done with 4G.
Cannot be done with 4G. Yeah, that's what. Yeah.
So now-
Cannot be done with 4G. That's why
No.
it's a challenge, guys. Oh, 5G, tell me what I cannot do with 4G that I can do with 5G, and then that's the challenge.
I
Right?
mean, very
No,
sorry.
but
But
then-
I think academia should stay out of this
But
because
I've been saying for some time it's time to get rid of Gs. Every mature technology
The
industry
industry
gets
will-
rid of these Gs.
oh,
at
believe
some
me, the
point.
industry has too much marketing invested on it, and there's too much money flying around.
Right, but
So
the
just like
claim-
with 4G, Verizon said,
But the claims being made, they're not scalable, right?
no.
So if you take 1 gigabit per second with millisecond
Makes no
latency,
sense.
you have to block the whole network to do that, right?
There's no backhaul to do it, there's no revenue to pay for it, it's just marketing. Remember 4G, when Verizon declared they were commercially deploying 4G, all they did was current aggregation. I mean,
But
so,
what's
okay, so
nice-
instead of one channel, you use 2 channels, now this is 4G. But marketing
But
wise,
what is nice
Marketing
about-
wise, that's
What
what.
was nice about 4G is it was a steady evolution which was.
there goes my point.
Right.
So one can poo-poo at the early stages,
Yeah.
4G was nothing. And yet today is the workhorse to do mobile internet
But there was
access.
far less hype around, there was
So-
much less hype with 4G.
Oh, it was a lot of hype.
There
No,
was
no, no,
some
we had
hype,
exactly
but-
the same.
No, no, lot of hype
Not
4G.
as
And who
much.
was first in 4G?
Not as much, we get calls from NSF, federal government about 5G.
About
I've
5G?
been called to
Yeah.
give
Well-
talks in many places just because they think 5G is some big deal.
Well, this time
They
around,
need
what's
to
different is
understand.
the revenue of the big guys whether providers or vendors, has flattened out for the last 4 or 5
But
years.
that's the
So they're
commodity,
creating all this,
that's the commoditization phenomenon.
but they're trying to create this excitement to see if they can
But
somehow-
but what people need to do is work with solutions providers
Yeah,
to make
yeah.
solutions.
Yeah.
So you guys should get a contract from Nokia because they're going around talking mostly
Yeah.
about these.
No,
I'm sure they are talking to,
Yeah.
I'm sure you are talking to both service providers and
Yeah,
vendors.
we are service providers. Like in
Maybe they requested this
we
study,
are
I
working
don't know.
Ericsson, for example.
Huh?
Ericsson,
Yeah.
Ericsson, Huawei, they're providing us the the infrastructure. Not Huawei.
Not Huawei.
Ericsson is giving us the. We
Yeah,
are,
that's fascinating, fascinating stuff.
okay, thank you.
Okay.
Thanks.
Not Huawei today.
Yeah.